Hi, this is Shady Atia, professor at Liège University in Belgium, and today's presentation is about uncertainty and error in statistical analysis. It's a very important presentation on the validation of your observation research and how you report it when you are conducting statistical analysis. Well, today's presentation is a part of a playlist on observational research. I hope you watched previous videos, and I need to remind you that we are here focused in this playlist on the quantitative research methodology, namely observational or correlation research. Now, the objective of today's presentation is to help you to understand the main statistical validation methods for observational research and to make sure that the statistical analysis, the statistical controls, the sampling mechanism, and the reporting of your statistical work is appropriately performed and well described in any study that you are sharing with others. I'm going to talk today about an introduction about the importance of validation in observational research, the biases in statistics, the three famous errors that we perform when we conduct observational research, and some validation strategy advices and tips, and finally some takeaway messages. Let's start first about the introduction and the importance of validation in observational research. Well, before starting any statistical research study, we need always to be aware about the objective of our research. And as you can see, there are 6 main objectives. First of all is to describe the sample or target population. The second objective of conducting statistics is to detect variance. Number 3 is to compare and test the hypotheses. Number 4 is to establish association and correlation. Number 5 is to predict. And number 6 is to prove causality. So you need to be aware that any test you are conducting, you need to know which test you are conducting for which purpose in statistical stages. Now, when we look at the particularity of observational research compared to experimental research, for example, or qualitative research, we can see that observational research has 2 main features. It requires a large number of observations, and it depends also on large number of variables. This makes it more vulnerable for making mistakes, and this means that it's more difficult to make an appropriate finding without having a high uncertainty and without having high ranges of error. Therefore, it's very important to be having a high awareness about validity and the importance of validity in observational research. And this means also that you need to be reading a lot in your field and in your domain, because the previous studies do not only help you to identify your analysis factors or indicators, but also they will help you to identify the threshold limits and the accepted limits in any research field community, meaning that when you conduct certain tests and you have some data, you will be better able to interpret it and understand what does it mean when you come with statistical test findings and results. Now, we need to be aware that we have 2 types of statistical analysis, descriptive statistics and inferential statistics. In both cases, we need to make sure that we have good validation tests and that we every time communicating and sharing the level of uncertainty and the range of error of our statistical data collection technique or of our statistical testing. Now, let's move to the biases or the bias in statistics, and why is this something happening very often? Well, we can say and generalize that for every statistical test, there is a perfect human bias, and we need to be aware about that. Statistics in general is a wide and theoretical field that is very strongly context specific. It depends on the field of the research where it is applied and its relevance, and therefore it is depending on what has been done before, and therefore you need to connect to the body of literature. The second thing that is important with statistics is that to investigate a causality or a correlation in any field, researchers have first to identify similar studies, pick up the indicators or the key performance indicators or the factors that were used, and then try to replicate those studies so that they are able to then conduct their study with a higher level of reliability. So the bias can come very easily by not performing these best practices, and because like I told you, it's based on a theoretical domain, a lot of mathematical models that are too abstract, you can easily become disconnected from the reality, and with manipulation of data, result of having very high uncertainty, very big errors, mistakes in your results, which makes the whole observational research outcome unreliable. Now, when we look at the data collection process and the statistical analysis process, it's not only important to focus on how did we analyze our data, how did we collect our data. No, it's also very important to ask ourselves, how did we validate our data? How did we assess the validity of our observation? And how did we report, or what kind of uncertainty indicators did we communicate? Did we evaluate the accuracy of the results? How far are we uncertain of the findings? What could be a potential error range for our findings? Because at the end of the day, it will be almost impossible to come up with a very high confidence interval like we do in experimental research. Experimental research, we can neutralize the effect of extraneous or profound variables. But in observational research, we are doing our experiment in real conditions, in real settings. We have a multiple factorial approach. We have a cocktail effect problem, and this means that it's very important to report our findings, but we are 100% sure it's not 100% evidence. We therefore need to communicate the level of uncertainty and the range of error. Now, what can we do in this sense? We can conduct our validity activities as part of reporting. So we can report on the validity, for example, on the data. We can report on the validity of the test that we conducted. And here I have some advices for you that you can use this checklist when you are validating your data. When it comes to data, one of the main things we will look at, first of all, is the originality of the data. First of all, we will inquire and check and ask ourselves, are we going to use data that is produced by ourselves, we collected the data, or it's a secondary data? This is the first question to ask. If we have primary data collected by ourselves, then most probably if we are using a survey or a questionnaire, we need to ask ourselves 3 questions. First of all, we have to ask ourselves, is the questionnaire survey direct, unambiguous, unbiased? Did we involve a linguistic expert? Did we check the wording? Did we make sure that the respondents or the subjects understand properly? Are we really measuring the variable? Do we have another alternative than the wording of measuring the alternative? Do we have a measurement or a monitoring for the same parameter that we are trying to get the subject's perception about? So these are all measures to check the directness, the inambiguity, the unbias of our questionnaire. Second action when we are talking about the questionnaire and survey is to check, is the sampling representative of the population, and is it rigorously done following best practices and scientific methods? Did we take care of randomization? Did we take care of representation? Did we communicate our sampling framework? And so on. So this would be a second step for validation and quality measure to make sure that we have a quality data. Third thing that could be done with questionnaires and surveys is to ask ourselves, have the authors provided the full questionnaire used in the study and they made it available to the readers? So this is a third measure that could be done in order to report on the measures of validating and improving the quality of your research. Now, if we are conducting research and we are not using primary data, but we are using secondary data, then we can have another type of questions that we can ask ourselves. Now, assuming this data comes from a government database, an organization, from a website, from records, and so on. So this data is synthetic. We collected it already from others' resources, and we try to create our own new data set, and it's a secondary data set. Then we ask ourselves, were these data collecting using variables that makes the study unique? Very important question, and it could be answered within the context of your scientific community and with your peers. The second question would be, is the collection of secondary data or of value for the research community? Again, a question that can be answered by attending conferences. Is the data that you collected valuable for the community or not? And finally, you can ask yourself, do the authors provide the protocols for collecting and creating these secondary data set or not? If the answers for these questions are all positive, then you can carry on, and then you are on the right track, that from the beginning the data that you are using, it is valuable, it is original, and it can promise to have valuable outcomes after conducting the statistical tests. Now, for the statistical tests, you can conduct other types of questions, and here we are talking about different types of questions that could be conducted. Excuse me for that, I just go back. Here we are talking about questions that can be reported, and a journal like Nature requires this validation reporting. For example, you must have a report summary and they will ask you the following, for example. Do you have a statement on whether the measurements were taken from distinct samples or whether the same sample was measured repeatedly? So this is a quality measure. You repeatedly measured the sample. Another important question would be, do you have a full description of the statistical parameters, including central tendencies, or other basic estimates like the regression coefficient? And do you have reporting on the variation, for example, the standard variation, or associated estimates of the uncertainty? In other words, the confidence level of your outcomes. So if you are calculating your confidence interval, you can use it to communicate the level of uncertainty of your estimations. Because again, statistics at the end of the day, it's an estimation. So you need to communicate all the time the level of uncertainty. And finally, one of the common questions that you will need to report also will be for the null hypothesis testing, and the statistical tests, which confidence intervals, effect size, degree of freedom, and p-value did you calculate? So another very specific question asking you, how did you manipulate or how did you investigate the influence of the confidence interval? How did you investigate the influence of your size of your sample and its effect? How did you investigate the degree of freedom of your test? And how did you investigate the p-value? So these are all requirements that you will find them anyway required if you are submitting an article in a highly reputable journal using observational research methods and statistical analysis. So early on you can use those two reporting checklists that I just presented on the data quality and on the statistical test quality to make sure that you'll be able to communicate the level of uncertainty, the range of error of your findings. Now allow me to move to the following mistake that many researchers using statistical research perform, which is using small samples or confusing causation with correlation, or manipulating the p-value by conducting flexible analysis and performing the famous p-hacking tricks. So allow me to explain each of them in detail. Well, when we talk about the use of small sample size, this is a very common error that happens in statistical analysis. Here, when a sample size is small, one can only detect large effects, thereby leaving high uncertainty around the estimate of the true effect size and leading to an overestimating of the actual effect size. So we need to avoid that, and a small sample size means that the distribution of the sample is more likely to deviate from the normality, and the limited sample size makes it often impossible to rigorously test the assumption of normality. So this is a big problem and we need to avoid it. And in this sense, what can we do? Well, there is different measures to counter those problems. A single effect size or a single p-value from a small sample is of a limited value, so take care of that. And the researcher should then present a priori statistical power analysis or perform a replication and repeat the sampling in a random way to increase the sample size. So those are some measures that could be done to counter this problem. The second very famous problem is confusing causation with correlation. Well, correlated occurrences may reflect direct or reverse causation, but can also be due to an unknown common cause, or they may be a result of a simple coincidence. So we cannot every time establish a causation if we find an association or a correlation of our data set. So we need to be so aware about it and we need to take care of that. And how can we counter this problem? Actually, we can introduce or test a third variable. We can interpret our results in a larger context and with peers. We can repeat our observation and we can also investigate the influence on time. If all these tests and checks for causality succeed, then we can only be certain that there is a causation. If not, then we are only stopping our study by saying or claiming that there is a correlation or an association. Now let's move to the third common error that is done in statistical analysis, which is the p-hacking, or the flexibility of analysis, that you keep running your p-tests in a p-value test in a very flexible way, resulting that you are hacking the results. And here we are talking about using flexibility in data analysis increases the probability of obtaining significant p-values, and this includes switched outcome parameters, adding covariates, undetermined or erratic pre-processing pipeline, post hoc outlier calculation, or subject exclusion. And by playing these data out, you will end up having a big problem, and this problem can be preempted by using standardized analytic approaches, pre-registration, for example, of the design and analysis. This is the only way to avoid the p-hacking and show that you were serious early on and that you did not exercise the p-hacking for your statistical tests. Well, also another part of the solution is that this problem can be preempted by using standardized analytic approaches. The best way is to prevent p-hacking is to show some tolerance to borderline or non-significant results. No problem, you can say I don't have significant results all the time. And in other words, if the study is well designed, executed, and analyzed, reviewers should not punish you. You will not be punished if you have a null hypothesis. It is not always the case, but this requires a high level of maturity of your research community. You need to have a journal editor who is really well educated and has an experience and well exposed, not only an editor who has a very narrow experience sitting just desk rejecting people. You need really to have an editor with a vision and a long track record experience, and a community that is sensitive to the nature of the problem that you are tackling. And you need also to make sure that the problem you are working on or the parameters that you are investigating are of a high relevance to the scientific community. So these are the advices to avoid the p-hacking, or even if you have non-significant results, to go around it and keep continuing your work. Now this brings us almost to the end. Let me talk now about the importance of having a validation toolkit or strategy to make sure that you will be always on shape and ready, and designing your observational research early on, taking into account this validation step, and being very aware that statistical analysis is very theoretical domain, and we can have an estimate of something but never a high certainty about our conclusions. We need to be aware when we're talking about observational research that we are talking about external validity and internal validity. External validity is our ability to do generalization, so generalization of the results of a larger population, and it is relevant, for instance, in a testing research. And internal validity will be related to the researcher's measurement and the precision of what we intended to measure. Did we really measure what we intended to do? Can the observed effects in the dependent variable be attributed to the change in the independent variable? Is it really this correlation? So the only way to make sure that we are having a high validity of our research and a low uncertainty, low range of error, is to invest a lot in the external validity through generalization. And as you learned during this playlist, generalization can only be achieved through randomization and through the replication of your statistical test and the increase of the sample size. Those are the only ways: the frequency and the replication, the randomization of your test, and having a large sample representing the community. If you achieve that, then you can generalize. And when it comes to internal validity, you need to make sure that you are really hitting the nail, meaning that your questionnaire or the observation you are conducting or the parameter that you are monitoring, it is really influential or not. Does it match the intention or the reality or not? And this is the only way is to do that, is to investigate and research, do a lot of statistical tests of correlation, and try to check if there is a causal relationship or not. So this is the first step to take into account. Now, when we talk about validity or external validity, again, we are looking to assess the validity of applying the conclusions of the scientific study outside the context of our study? And is the answer valid for other cases? Can we generalize it? Can we move our results in other contexts? Can we have different place settings will influence the result or not? If we put the results or try to test our findings in with another population, is it going to work or not? Is the results influenced by the temporality, by the time? If we put it in a different time, in a different season, in a different moment, are we going to have the results? So the external validity is enhanced by replication. And if we can repeat the study and get the same results, then we will have a very high external validity, which means that I will conduct my observation in different countries or in different populations or with different subjects in different times. And this replication and having the same consistent results will increase the external validity. When it comes to internal validity, here will be the ability to describe the extent to which a cause and effect relation is established in the study, and there is no other extraneous factors that are influencing the outcomes, and this means that I need to make sure that I am free of bias. So how can we improve our internal validity of our research? Is that we have to conduct the correlationals, but in order to reduce the internal validity, we can look at the demand characteristics. When participants are unsure of what to do, they will seek cues, and then this can influence and bias the results. If we have the investigator effect, who is collecting the data or conducting the observation, can influence the behavior or influence the result of the observations or the monitoring. The situational variables, the climate, the environment, the participant variables themselves, the differences between individuals, because again, we are not in an experimental setting, we are in a real world settings. So the only way to improve the internal validity is to take care of these four aspects and to try as much as possible make sure that we are having our hands on the factors that influence the results. Now, as I told you, randomization is so important in this process, so we will use randomization. We will need to calculate the confidence interval. We will need to conduct several samples, and every time we will calculate the mean. And once we have this mean, we will calculate the overall range of the different means, and this will be the only way to calculate the confidence interval. So the confidence interval will be the range of the different means of our different samples that we try to collect and replicate to represent the whole population, and communicating or sharing the confidence interval is a very good best practice, because based on that I can communicate and share the level of uncertainty. So a description of the randomization and the statistical test is required in this case, and the study must always include the description of the blinding. Did I have a blinding effect? Did I have somebody else conducting the same observations? Did I conduct the observation in other conditions? These are all influential parameters. Did I anonymize my sampling technique to check how the results will be similar or not? The other thing is to replicate, so try to have a repetition of your measurement so that the variability associated with the phenomenon can be better estimated. So this is also a measure of validity, and all studies must disclose on the replication even when this disclosure is negative. So if you're doing a professional reporting, you must always disclose on the replication even if it was not done. And for sure, replication is important because it is this replication that will allow us to estimate the statistical error. I cannot calculate a statistical error without repeating my experiment or my data collection process several times, without repeating the sampling process, repeating my observations. And then once I estimate the statistical error, I can reduce the statistical error, I can increase the precision of my data collection process through subjects, humans, or through monitoring, and then I can ensure that the analysis does not rely on subjective methods. So actually, the enhancement of external validity is possible if the observation can be repeated with the same results. This will lead to a high external validity. Well, some final tips for you in order to move on with the next step in your validation and make sure that you are with confidence able to communicate the uncertainty and the range of error of your statistical tests. So first of all, I advise to conduct some bias and statistical analysis avoidance. You know, you need to be aware about the whole process. When we are conducting statistical analysis, we will start with descriptive analysis. We will ask ourselves, do you want to map and describe the variables at a point in time or over a period of time? And here you can have some causal results, like does the exchange of X influence Y? Also, you need to investigate what is the type of data you are working on. Are you using primary data? Are you using secondary data? What are the costs associated with your choices? Is this data accessible? Do I have it beforehand? What are the resources required to get this data? What are the confidentiality terms and so on, the privacy terms? What is the time and geographical location dimension? Can I have a cross-sectional statistical test because I have a high representation? Can I have a long time calculation? Do I have a panel data? Am I going to use regional data or urban data? Am I representing the whole geographical population geographically or not? And here I have to ask myself, is it possible to have these collection methods? And I need to consider the current situation and not forget that this all will take huge amount of time. So I need to take care of my design of my experiment, my design of my statistical tests. I need to take care of the data of my statistics that I'm going to use. And then finally, I need to check my test that I'm going to conduct. What are the common tests used in my field? Am I going to do descriptive statistics, or am I going to do inferential or parametric statistics? And even within the parametric and inferential statistics, what kind of test I'm going to conduct? Am I going to do comparative statistics? I'm checking a hypothesis. I'm going to check correlation. I'm going to do clustering. I'm going to do modeling. These are all important questions. So sometimes less is better, and it's not about the amount of tests. Describe your data, and the variance is the beginning of being able to go for advanced types of inferential tests. If there is no variance, then you cannot carry on. So it's very important to come up first with the basic test, the p-value, the chi-square test, and so on, what we described earlier. And if you have variance, then you can move on. So you need to be aware about this whole process of designing your statistical test, and you need to be ready to design, check the data quality, and select very few tests that will bring you closer to your findings. My advice in general is to describe and test the relationships or examine the cause and effect relationships only if there's variance. Emphasize the objective of your measurements. Rely on statistical, mathematical, or numerical analysis of data, whether you are using primary or secondary data sets. And this will typically involve counting and measurement. So this is the nature of statistical analysis. Also take care of your data and your determination of probability. The claim that a set of observed data are not the result of chance needs to be proved through several tests. So this could be attributed to specific case. So make sure that you have a better representation of your population and you don't have an unsymmetric case, or your chi-square test distribution shows a skewed or imbalanced symmetrical distribution of data. The normal distribution data and the non-normal distribution data can influence your tests and influence your results. So this is also a very important point to take care of about. Measure the statistical significance. The statistical significance, or the p-value, is crucial. You cannot report any statistical test without the p-value. Measure the strength of the evidence against the null hypothesis. A high p-value means that your data is highly compatible with the null hypothesis, and a small p-value provides evidence against the null hypothesis, as it means that your result would be very improbable if the null hypothesis were true. So always calculate your p-value and communicate it as part of your uncertainty communication and range of error communication for your statistical test. The uncertainty is very important. Like I told you, I prefer always to communicate in statistic the uncertainty. I don't like to say the confidence, level of confidence, because I think at the end it must be an estimation. We never have the full population. It's always a sample which is part of a population, resulting that we are still theoretical, and the range of error could be very high, resulting that we need to be modest. And rather than talking about the confidence interval, it's better to talk about the uncertainty range. So the sample should be used to draw the conclusion on the population. Here there is an abstraction. The abstraction will lead that the confidence will be low, so the uncertainty will be high. Therefore, a sample is never perfect representation of the population, and there will be always a sampling error, and therefore I will need always to communicate the uncertainty. Now, the confidence interval, the p-value, could be a proxy for calculating your uncertainty, and it will communicate how accurate the estimate of a parameter or of your population is likely to be. So here you can measure the widths of the confidence interval affected by the variation or affected by the sample size, and you can see if you have a low variation in the population and low variation in the sample, you will have a very narrow confidence interval, and if you have a great variation in the population and great variation in the sample, you will have a wide confidence interval. Therefore, it's very important to report these findings. In general, what would affect your widths of confidence intervals? Like I said, the variation of the sample, so we need more variance, the sample size, we need larger samples, and the elimination of confounding variables, we will need to be very conscious about that. So to come up to the conclusion, uncertainty evaluation is very important, and the question will be always what affects the widths of your confidence interval, the variation, the sample size, the elimination. The narrower the confidence interval are, the surer we are, and the larger the confidence interval are, the less we are sure. So by that we can communicate the level of uncertainty or the level of confidence, and based on that we can say, okay, our result communicates how far we are confident about our result or uncertain about the findings in relation to the sharing, the sampling error, the sample, and your population. This is the only way to do it. The sample error in this way will be helpful because we will measure the variation of the sampling different sample giving the results, and we will not communicate only one point of time. It will not be one point, it will be always a range. So I need to say, okay, what is the level of uncertainty, what is the range of error, and the range of error is always a range. It's not only one point in time. And here I invite you to apply the confidence interval formula or the p-value formula, which is so important and so critical to calculate the level of confidence and then later translate it into an uncertainty level. So again, this is the reminder of taking care of the variation of the sample size, and the elimination. And again, the narrower the confidence interval are, the surer we are. We want to have a narrow confidence interval. If you don't have a narrow confidence interval, then you have to communicate that as soon as possible. And therefore I say I prefer to use the uncertainty. So just reverse your confidence interval. Now, make sure always when you are conducting validity activities to check the internal consistency. Internal validity, we mentioned earlier, describes the extent to which a cause and effect relationship established in the study cannot be explained. So I need to ask myself, my results is free of bias or not? And I need to perform a reproducibility to make sure that I can assess the generalizability of my research findings, and that in other contexts with other subjects, the same results will be there. Well, this is it of today's presentation on uncertainty and error calculation in statistical analysis. Some takeaway messages: don't forget the 3R principle in observational research: randomization, reproducing, and the blindness and the reproduction or the replication. Those are very important actions that we need always to remind ourselves about and exercise them. When we talk about uncertainty and error, for every statistical test, there is a perfect human bias. Statistic is a wide and theoretical field that is very strongly context-specific and biased and too abstract. Involving teams of rivals is a very good practice. Transparency is a good practice. Try to have blind analysis. That are the only ways, those are the only 3 ways to avoid misleading results and hacking results. Make sure also that the variation of the sample, its size, reporting the confounding variable influence, and reporting the uncertainty and the error range are part of any results. And randomization for sure will assure that there is no confounding, and randomization will help you with any imbalances in the covariates that could arise by chance. That's the most important part to take care of in your analysis. And for sure, you need to calculate and share the uncertainty and error values all the time with all members. And finally, I always advise you to seek statistical training courses to be deeper educated and be better aware and equipped with all these problems that you encounter, whether on the level of the design of your experiment, design of your observational test, or on the level of the data collection, or on the level of the choice of the test that you want to perform. Well, that's it with today's presentation. Today's presentation was a playlist on observational research. I hope you watch then future videos that you are going to produce. This was the end of the playlist on observational research, and I hope you learned from it and benefited it. It was a very long playlist on uncertainty and error calculation in statistical analysis. Thank you very much. This is the end of the observational research playlist. I hope you will learn from it and share it with others. Thank you very much.